Hello, algebra students. Today we're looking at another set of factoring examples. But before we factored, I thought we'd look at how the factors go back to the original parabola to begin with. So I thought we'd build a couple parabolas. Yeah? So the first parabola I want to build has zeros 4 and negative 13. Now what do you guys think? How many parabolas might there be that have those two zeros? Is there just one that exists out there in the world? There's an infinite number, right? Like they could be all kinds of different steepnesses. Let's see where we can put that at the end. But first, let's just make it have those zeros, and we'll go from there, okay? So can you guys help me? How would you get a 0 of 4? It's not like you're playing guess the parabola and it's going to be like a really abstract kind of thing. You should be thinking about the factor that 4 comes from. What factor produces a 0 of 4? Well, the factor that produces a 0 of 4 is going to be x, not plus 4, but minus 4. If you set that equal to 0, you'll get 4. Yep. So that's the factor that will produce 4. What factor will produce negative 13 then?
X plus 13.
Yes. So we're going to have x plus 13. And we want to multiply those two factors together, those two quantities together, because that's what lets us use the zero product property in the first place, right? So this parabola, in fact, will give you those zeros. There's an infinite number of other ones. But that doesn't look very parabola-ish to me, does it to you guys? Like, it looks like factors. So you need to expand it in order to actually finish this problem, to see the true parabola. So we're going to do the FOIL thing. I don't like the word FOIL because it only works in cases like this. It won't work on this one. So expand, distribute, multiply everything by everything. That's what you're going to do here. So I'm going to say x times x is what? X squared. I'm glad I didn't hear any 2x's. That's x plus x. Then x times 13 is, well, pretty boring. 13x. We finished this guy. Now we're moving on to this guy. So now negative 4 times that x is minus 4x, and negative 4 times 13 is negative 52. Might need to whip out your calculator for that, which should be fine. Combine any like terms? Any like terms? So that's what, 9? There is one parabola which will have the zeros of 4 and negative 13. You guys said there were an infinite number of other ones. How could you get those other ones? Well, you could come in here and say, well, I'm going to multiply this entire parabola by 2. That would be a steeper one that goes through the same spots. Or you could multiply everything by 3, an even steeper one that goes through the same spots. Or you could multiply everything by a half. That'd be a flatter parabola that would go through the same spots. You guys get the idea? So that's one of the possibilities, and that's probably the way you want to approach your problems. So I thought we'd go a little bit further and build not a parabola, but a higher order polynomial. Parabolas have 2 zeros. Parabolas could also have 1 0, right? If it was just sitting right on the axis, that would be possible. Rare, but possible. And they also have 0 0 sometimes when they don't touch the axis at all. We saw one like that in the calculator yesterday, right? Polynomials with 3 zeros are higher order, but you can do them the same way as this. So how would I build this polynomial that goes through the x-axis at 2, negative 1, and 4? Kyle?
Do you go x minus 2, x plus 1, and x minus 4?
Yes, sir. I could call that like f of x, and we'd have a polynomial that does it. That's the factored form of f of x. If we wanted to create its nicer form, we could do exactly what we did up here and distribute. I'm going to take 2 at a time. So first I'm going to do these 2. So that's going to be x squared plus x, 1x, minus 2x, minus 2. Combine like terms, and here we've got 1 minus 2 is minus 1. And then you could continue. See, FOIL doesn't work anymore because there's more than one inside. So just distribute everything times everything. So we've got x squared times x. That's x cubed. X squared times that's minus 4x squared. This times that is minus another x squared. This times that is plus 4x. This times that is minus 2x. This times that is plus 8. Then I come in here and say, any like terms? yes, these, and the squared ones. So ultimately, we're going to get x cubed minus 5x squared, 2x, and 8. That is a third degree polynomial. In other words, a cubic curve. We're going to look at those soon enough. Cubic curves look like snakes. So let's go back to factoring though. The whole point of this is to learn how to apply factoring to find zeros. So a couple little bit tougher problems today, if you guys can help me with those. So we're going to go beyond Algebra 1, I think, a little bit. These I think you might have seen how to do in Algebra 1 though. To find the zeros, what do I put 0 in for? Do I put it in for x first? No, because that's the y-intercept. Zeros are the x-intercept, so y is 0. Okay. The thing that screws this one up from being a simple standard trinomial is that's not 1. That's supposed to be 1. If you want to play the combinations of 28 game. Is there something we can do to make this easier though? Aubrey?
Divide by 2.
Yeah, just get rid of it. This time 2 goes into those other ones pretty nice, doesn't it? That's definitely the smartest way to do this one. So just there? Just there?
No.
See, I see this on tests a lot. I see people do that, which is actually works out to be right, but it's only legal because Old Testament rule says you do something to one side, you have to do it to the other side, and 0 divided by anything works out to be 0, so it's pretty nice there. Okay, let's see if this one factors now. Does it? Bless you. Not a whole lot of options for 14, but 7 and 2 get the job done this time, don't they? Bless you. Oh, oops. Plus plus? So what can I stick there to make that factor 0? Negative 2. What can I stick there to make that factor 0? So those are the two x-intercepts for that parabola. Okay? So I think Aubrey's suggestion of dividing out that inconvenient a to make this a standard trinomial was a good idea. Here's another one that's really similar. Can I approach it the same way? This time you'd want to divide by 6 to get this to be 1, right? And you can divide both sides by 6. I guess I should put 0 in first, right? Trying to find the zeros. And it'll work nicely on those two, the A and the C, but what about the B? It's going to be 5/6, and then we're really going to have to think cleverly to come up with the correct combination. We're going to have to think of things that are fractions, and that's probably just not going to be super beneficial for us, I don't think. So instead of doing it this way, let's go back to that algorithm that we looked at once yesterday, and it's new if you're watching the video. So, what do? You have to run through this usually a few times before you get it down. But like in high school, my teachers never showed me anything like this. They just said, guess the answer immediately. Go from right there to the answer. And I was like, but it's hard sometimes. It's really hard for me sometimes. And I could get it sometimes, but sometimes I couldn't. And like even into calculus, when I had to figure out how to factor something like this, it always wasted my time. And once you get good at this algorithm, it'll take a few times of going through it, you'll get fast. So first, you multiply those two numbers, A and C. Then you look at not just factors of -6, but of this combination. 36, like 6 times 6, but those won't give me like 5 somehow, right? What's another thing that gives you 36? You can whip out your calculator if you need to. But 9 and 4. Might 9 and 4 somehow give me -5? That's the one.
-9.
-9. There we go. So now I'm going to say, all right, leave the 6x squared alone. I'm going to say equals 0, right? Leave the -6 alone. Use this combination of x's. Negative 5x is negative 9x plus 4x, right? There's all kinds of other ways you could write it, but that's the clever one. Because now this will factor by grouping. So this is just using your other factoring techniques in a different arrangement. These share what? These two terms?
3x.
3 and x, yes. What's left? 2x is left there. If I divide that, I'm going to get negative 3. What do these share? They share a 2. You guys want to go positive 2? A lot of the time you have a choice, positive or negative there. If yours isn't working out, try the negative. So what's left? 2x. Remember, when I say pull out, I mean divide. So if you pull 2 out of negative 6, and at that point, if these match, you know you've done your job correctly to that point. And then you just do it again. You do the same what they share game again. This looks different, but it's not. 1 term, 2 terms. Each of them share this big chunk. They have that quantity in common. What's left when you take it out of this? The 3x. What's left when you take it out of that? The 2. And this is all equal to 0. We can now use our zero product property, right? So it's an algorithm that has a few steps. Step 1, I guess, is like find the right combination of AC. Step 2 is write it down. Step 3 is play what they share on both sides. And step 4 is play what they share again. It takes a few times. Once you're good at it, though, it'll take you 20 or 30 seconds. If you bother to get good at it, you need to practice it a few times. If not, then it'll continue to haunt you. So it's up to you. So we need to set these equal to 0. So I'm going to add 3 and divide. There's one answer, 3 halves or 1.5. That's 1/0 of the parabola. Minus 2, minus 2. So negative 2/3 will be the other 0 of that parabola. I could draw it, right? But I'm not going to. It's going to be pretty steep, right? The 6. It's going to make it nice and steep through those spots. So, all right. Let's look at one more problem before we leave off for today. Or do you guys want to see another one of those? We'll practice another one afterwards, but not yet. Let's see one new factoring technique. So difference of squares goes like this. Can you guys help me factor this guy? X squared minus A squared. Just imagine A is some number. How's that factor? Something we should all have memorized after today. That's something that we should be familiar. There's 2 other versions of this as well for things that are not just squared. We just saw a cubic problem a second ago. We're going to see lots more of them over the course of this year. There's also a way to factor difference of cubes, or sum of cubes. Sum of squares doesn't factor for reasons we'll get into next week. It has to do with imaginary numbers, which you guys haven't seen yet. But difference and sums of cubes do factor. So help me figure this out. If you know one, you know both. How do you guys think this might start? That started with x minus a. Now what will we have to put here to get x cubed when we're multiplying? Yep. What would we have to put here to get this times this to be a cubed? Yep, I heard it a couple places. The answer is a squared. See, this isn't really a lot of memorization, honestly. And then the middle part might be a little bit awkward for now when we don't have tons of experience like we'll have by the end of the year. Any guesses, though? What goes in the middle? There's an x, and there's also an a that goes in the middle. And then a little bit of memorization. These are both plus. Each one of these factoring schemes, difference and sum of cubes, has 1 plus and 1 minus. Excuse me, 2 pluses and 1 minus. So we have 1 minus and 2 pluses. This goes exactly the same way. How do you think it starts though if this is plus? Now is this one going to be plus or minus if we want positive a cubed? It's got to be plus. And I told you there's one minus in each one, so it must be there for that. So I remembered this my sophomore year of high school was minus plus plus and plus minus plus. And I just kind of do it naturally. I just kind of write it down. You guys will be able to do that too, so if you practice. So let's do one example of where you might use this to find zeros, for instance. So you guys have been doing power tables this year. Pick a nice cubic number so that we get a nice answer instead of something more difficult. Let's not do like 8 or 27 though. Pick one of those big ones. 625. What was that? Wasn't that 5 to the 4th power?
Yeah, 125.
125 would be good. I think that's in your practice. Let's do an even bigger one. I like those goes.
4,000.
How about 7 cubed? What is 7 cubed? 343. Thank you, Aubrey. Nice. So let's factor x cubed minus 343. I just want to factor it. Finding the zeros is kind of something we'll do next semester. So, how would that go? X. And first you've got to realize it's easy to see what number or what thing is being cubed here. What thing is being cubed here? This is really 7 cubed. So I'm going to put 7 there. I'm going to put a minus. You got it? What am I going to put here? X squared. What am I going to put here? 7 squared, which is 49. In the middle?
7x.
An x and a 7. We'll say 7x. Minus plus plus. So there's one of our factors. The question is, does this quadratic, does this parabola factor more? Well, we've been working with those, right? Let's think about it. Does this guy factor more? Well, the only way it would is if 49 factored, right? 49 doesn't have a lot of choices. I think it just has 1 and 49 or 7 and 7. 7 and 7, is that somehow going to add up to 7? It could add up to like 14 or negative 14 or 0, but not 7. This is an unfactorable thing that produces imaginary solutions. We'll look at that next week. I'll see you next time. All right, so let's look at another example of non-standard trinomial factoring. So what do I do first, guys?
Multiply it.
So I get
40.
factors of 40, which will give me 18.
Negative 22.
Very nice. Okay, so this is going to be 10x squared, right?
Yes.
Minus 4, lots of space. Negative 20x, okay. Plus 2x. I don't think it matters which way you do those. Split it. These share 10x. That's what's left. These share 2. That's what's left. Did we do it right? Yeah. Those share x minus 2. You figured it out, Mr. Squire?
Yeah.
Sweet. That's what's left. You solve those, I'm just going to give you the short answer. You get 2 for the first one. What do you get for the second one? Negative 2 over 10, which is negative 1/5. Don't try to do that unless you're feeling like living dangerously. Okay? All right, so let's do one with the sum of cubes. So the sum of cubes, we're going to go, okay, this factor is like this. We've got x. What's being cubed here? Hopefully you recognize that from your power tables. 8 is being cubed here, so it's like a in the formula is 8. So then I put what here? X squared. What do I put here? 8 squared, which 8 squared is 64. I think I'd write it as 64, not 8 squared. Up to you. I mean, you can take another step. And then in the middle, we got to have an 8. I guess I should stick with my pattern. An 8. and an x. And plus starts with plus. Oh, so that must be the one that goes plus, minus plus. So one of the zeros for this snake curve, because it's cubic, right? One of the zeros for this snake curve is -8. This guy, I don't think factors. It has imaginary roots. You guys could try to factor it, right? You could play around with it for a while and say, well, factors is 64. We could go like 32 times 2, or 16 times 4, or 64 times 1. That's not going to give us -8, right? 8 times 8. If you mess with those for a second, though, you're going to see this guy doesn't factor. I think it has imaginary roots this time. Or does it? Can we get 8 out of those? Definitely not here, right? This would be like 16 or 0 or something. That'd be like 20 or maybe 12 or something like that, right? Not 8. Definitely not 8, 32 and 2. Maybe we're just missing the right combination. 64 is a lot of factors. 64 and 1 are going to give us 8 though, right? We're good? I don't think this guy factors. We'll see how to do that next time.